Um, okay, we're going to continue to work on homework assignment number two. Um, so homework assignment number two is really a core C++. I hope you learn well in this homework assignment. It shouldn't be too complicated, but try to convey a few very important principles about object-oriented programming. So in object-oriented programming, let me just re-emphasize what I said. What's the difference between so-called OOP, object-oriented programming, versus the traditional programming? The thinking, the construction about your design is actually taking a totally different approach. Instead of focus on the problem you try to solve, we try to focus on what are the objects to define or classes, whatever you want to use the term. And then we think about how this object will naturally interact with each other in this process is solve the problem. So the emphasis is more on the definition about the object rather than to solve the problem itself. I mean, of course, solving the problem is important. Ultimately, you need to solve the problem. In fact, a lot of the so-called algorithm and the method you learn to solve a sorting or a searching, whatever those problems, have been encapsulated inside the internal about object, and such that when you see, you can focus on a bigger picture, then try to directly focus on the lowest level of detail. I mean, this principle is very important. If you want to write a large program, you can imagine that if I gave you a program with about 75 million lines of code, which is a typical system that actually have a 75 million lines of code. If you try to understand all 75 million lines of code, it's impossible for any human being to really master each of the concept. However, in object-oriented programming, we encapsulate all the detail within the internal of the object. And what you only care is high-level abstraction called object or class, and see how they interact with each other. Then you can have a very accurate, a very abstracted, high-level understanding about how a system works. And then you, through the development of the object, you kind of move down, and then you eventually solve the problem. So this is very important. I'm not criticizing any other people, but there's a lot of people who claim they know C++ programming, they claim they know Python programming, but they never learn this important principle. So this homework might be the most important lesson you need to learn when you walk out of this class, okay? Okay, so last time I gave you an example, which is the instructor finished a lecture on Monday, and he went to a nearby bus station, and then he took a bus and met the student on the bus, and then the student get off at the hospital stop, and the professor continue to move on to the other location. And then after he got off the bus, he realized he lost his phone. Okay, so essentially, this is a scenario. Is if you think about, I only spent about a paragraph to describe the problem. This problem is quite hard. It's not only hard, but it's very innovative. Currently, we don't have a solution. I mean, no matter how well Google has provided a service, I mean, basically, this is a Google problem. Okay, this is a Google problem, but Google cannot solve this problem. I wanted to also give you a message. When we get used to a service, such as Google, such as Facebook, such as ChatGPT, what might surprise to you is that, in fact, they're not so innovative. You can think about your life and think about what problem you try to solve and try to put down a description like this and think about whether a service, I mean, I want you to think about in your life. By the way, this is another important lesson for object-oriented programming. is that once you learn about object programming, you see everybody is an object. You see a student is an object. You see the instructor is an object. You see your computer is an object. You see a bus is an object. You see a GPS location as object. You see a building as an object. So what you're thinking is, wow, I'm actually living a life which objects interact with each other. And then you think about the service you use every day, and you see that does that service really solve the problem of the object-oriented world? In most cases, the answer is no. And when you realize it's no, then you have opportunity to do something very innovative. All right. So in fact, there was a lots of this is amazing that once you start thinking about this, you start to understand what we call Silicon Valley style. In the Silicon Valley is the only place, well, I shouldn't say the only place, but the most interesting place that keep having innovation. So of course, innovation is related to technology, but a lot of innovation is actually started with how to solve a problem in the object-oriented world. Okay, so I want to keep in mind that this class is not just about learning a programming language, but thinking about embracing a paradigm that actually enable you to actually solve something much deeper and is practical and actually make an impact to our world. Okay, so I have this problem. I will argue. You can actually argue me back saying that, hey, wait a minute, I can do this with Google already. That's great. We can talk about that. But I want to present you today a process. And through this process, we not only learned about how to do object-oriented programming, we start to also know the language we're using, in this case, the C++. All right. So we have this case I hope you're familiar with. It's just talk about event happened within 2 hours. Instructor and the student and the bus driver. And then we basically go on to basically have some interaction. All right. So my number one objective, in fact, this is another important lesson. As a C++ programmer, guess what? The traditional way of teach C++, the first thing you need to learn is how do I design a class? Because what's the most important element in the language called C++? What's that plus plus? Above of C language is the class. So therefore, it's very naturally for you to think about, when you want to solve a problem, you think about, oh, I need to think about defining a class. But which is not wrong, by the way, but I want to introduce you something which is, I call it intermediate step. So before you can create a class, I want to think about, well, what should be the object? So if you only learned about C++, then you will realize, oh, wait a minute. I mean, if I don't create a class, how do I know what the object looks like? I mean, they're similar, of course. But I want to give you a intermediate step, that's why I focus a lot on JSON, JavaScript object notation. JavaScript object notation is a way for us to represent object from their data part. So the step one, I actually put this file and I will upload, is actually try to identify the object. So how do I identify the object? Is that I don't want to use natural language, because this is a description. This is like a brainstorming. A few students, you get together, you try to basically describe the problem in any way you like. And then you have to somehow introduce this intermediate representation called JSON, and such that it helps you to check whether the object you define have sufficiently or accurately represent the problem you try to solve. And furthermore, this representation can very easily help you to further to develop the C++ class. By the way, if you do this, if I want to use Python, I can actually convert that to Python. If I want to use Java as a language, I can convert to Java class as well. Okay, so this is a nice intermediate programming language neutral representation, which I can move on very easily. By the way, this is not done today, but this is another example of innovation. I believe in the future, the development of generative AI, they will automatically read this and generate the JSON, represent the object. And then there is an already existing tool that you can translate the JSON to any object you like, any class, like a C++, Java, or Python. That's okay. So in other words, this is going to be more and more automatic in the future of programming. In the future of programming, it's very important for you to understand there is an intermediate step which will enable AI be a tool to help programming. Okay, this is going to happen by the time you graduate. I will be very surprised if there are no intermediate tool to do this. Okay, so let's look at the example. So like what we did, we identified there was a few objects. By the way, those objects we define, I recollect how we interact. It's actually you guys translate. You should be proud of yourself because those who actually contribute the idea is actually come up with the idea from last week's lecture. I believe qualitatively much better than my original plan about how we should do this. So I'm actually feel very blessed to actually learn about that. So I kind of recreate the whole object representation. So the first one is no surprise, is timestamp. So how do we represent timestamp? We're using, by the way, we have a JD time. So I already put down this timestamp using the standard format. So there are timestamp, 4 timestamp. You can see that they all occurred on April 14th, which is the last Monday. And the first one started at 2 o'clock when the class ended. The second one is when I get on the bus. The instructor, probably the student as well, got on the bus. And the third timestamp is 2:45 when the student got off the bus at NCKU hospital. And the final timestamp is 3:15 p.m. when the instructor got off at Moore and Pull-Up. So if you check the description, you can actually verify. When I have this 4 object, you can actually verify the original description, whether it actually capture all 4 timestamps. That's actually we can catch from the short description. So this is important. If you think about that, timestamp is an object, but also extracting the timestamp from the description in natural language is essentially extracting the object component, some object component from that. Okay, so there might be more timestamp you can extract. This is usually, by the way, this extraction sometimes is not that, how do I say that? Not that unique. So when you actually read a piece of text, sometimes I can read the text from the service. But sometimes even more interesting is sometimes what I describe imply something which you can actually also extract from the text. For example, let me tell you that there was certain thing I didn't extract, but it might be useful to extract depending on how you want to let the object interact with each other. For example, because I'm following the route of the bus 77, right? I'm following the bus. So if I get on the bus at Changrong Station, if the student got off the bus at the NCKU hospital, then essentially both of us have stopped at a certain time between Changrong Station and NCKU hospital. That's the information you can derive. But whether that object is necessary for you to include it in interpretation of this piece of requirement is actually by design. Sometimes you found this is useful, sometimes you found this is not useful. Because, well, what happened if I just give you a crazy example? What happened if I just at the time I arrive at the station between these two stations, I actually just crazy, I throw my phone out of the window of the bus. So which means that my phone might be actually at that location at that time. So that's just an example, whether you believe that is a possibility you want to catch. Okay, so that's the timestamp currently I set up for. I want to give you an example. The way I describe it, following a specific format. So I want to do this not just about describing, but I have a format. That's because I know I want to do C++ programming. I want to, based on this object, I can reverse engineer into a definition of class, which I eventually using JSON. So I can define a new class, or I can actually try to find a class that's actually closest to that. Okay, so whether this later, I will tell you, you have probably seen me have all the object has a function called dump to JSON, right? Has a function called dump to JSON. So the thing I'm saying that, okay, I'm expecting to create a class that's actually represent the information looks like this. That's number one. I want to define a class which will have this equivalent of information. But on the other hand, the second one, I said, well, I have already a lot of classes defined that the Professor Wu already put it there. I want to find out which one is actually closest to the one I like, and such that I can reuse it or I can inherit from it, right, to improve. So how do I do that? That's why we want to have this function for every single class called dump to JSON. So what dump to JSON is that you have a C++ class. I want you to go the other way to say, well, if I create an object, then what should be the JSON representation of that object? So in other words, when I'm looking at this side, I have a lot of class. And basically, assuming you can do this manually, you have all the class and you create some object, you can generate the JSON to see how well it match. That's another way to look at it. But if you're a programmer, you're familiar with the system, you kind of already familiar with, okay, what kind of representation. So sometimes this is good enough for you to be able to find the correct match. But believe me, when the system getting really big, we're talking about in the example I gave you is probably less than 100 class. Okay, that 100 classes is not a big number. But what happens if you have 1 million classes? Then you need to have some way to kind of narrow down about what are the class that's actually best match with what you want to do, what you want to design. So in other words, I'm telling you, in object programming, we prefer reusability. If somebody already developed the class, we try to use it, not to develop from the scratch, unless you realize you have some very good reason to define a new class, then you define. Okay, so that's kind of the timestamp story. Okay, let's look at something even more interesting. Then we talk about person, right? We talk about the person object. So in the person object, we have a 3 person. We have a 1 person called the instructor and the EE1520 student. And we have the other one, which is a psychology student who happen to be the driver of the bus. Okay, we have 3 persons we like to try to do something. So let me actually tell you that. So now we cannot just easily just reusing a class, because now we realize we want to have a concept called traceable person. So this part is really interesting. That's why I give credit to you guys. Okay, you should be really proud of yourself as a team, which is the concept is I want to have a GPS traces and associated with a person. By the way, this itself is not really innovative, because Google Map already have this capability. If you're not aware of all this information being sent back to the cloud, that Google control to do a lot of interesting application. Okay, so we have to extend it. Okay, so let's actually take a look at that. So we actually, the objectives, I actually put it here. I said finding the suitable class to either to inherit or to contain. Okay, I'm using two different terms. One is to inherit a class. The other one is called to contain. Okay, I'm going to give you an example. What's the difference? Essentially, when you want to construct a class, when you want to reusing the existing class, you don't have to only use inheritance. You can use the other one called containment. You want to contain another class. I will give you a specific example in 1 minute. So just to let you know, if you never heard about this term, in object-oriented programming, there's two hierarchy. One is what we call inheritance hierarchy. One is we call containment hierarchy. So essentially, these two represent the two most important way for you to reuse another class that's being defined already. Okay, so you heard me, you will hear me saying reuse or reusability. That's the approach, the paradigm of object programming. Okay, so this one is the original. I kind of simplify a little bit. This is a class person. It only have a name, Felix Wu. Okay, by the way, in this case, I simplify a lot. Okay, I'm assuming there are more information, but I only list it here. So this is an original class person. I only have a one. But now I'm actually going to define something called traceable person. And inside traceable person, I'm actually going to put it down a little bit. You see that? Okay, starting from this line, let me highlight it. Starting from this line all the way down is the new thing I'm actually introducing. I mean, of course, I add another attribute called occupation, but that's a minor one. Whether you have it or not have it, I don't really care at this moment. But this part is interesting. It's called GPS trace. It's called GPS trace. Okay, let me test your understanding about JSON syntax. What's the bracket means in JSON? What does this mean? If in JSON you see a bracket. By the way, this is called curly bracket. This is called bracket. Okay. What's the meaning of bracket? It's an array. Thank you. Thank you very much. That's accurate. That's great. That's great. So essentially what I'm recording is that I want to check where you are at each of the time stamp. So I represent that. So it's an array of what we call time location. Means that you have a time, you have a location. So let's actually take a look at this important representation. So you can see my first, by the way, I will highlight each of the element is an object. So I'm going to highlight from this side to this side. So an array is a sequence of something. Something could be an object, could be an integer, could be a floating point, could be pretty much anything. Could be another array, by the way. You could have that as well. So what is an array? A sequence of something. All right. So let's take a look at the first element of the array. The way I describe, you can see that what's the syntax is that it started with a curly bracket. It ended with curly bracket with a comma. So this comma represents that's the endpoint about the previous array element. Okay, this is the first array element. It started from here, right after the bracket. It started from the next character and then ended before the comma. Okay, of course it needs to match. Okay, so this curly bracket match this one. Okay, so let's actually take a look at the representation. So the representation is what I call is a time location. I've integrated the concept of time with the GPS location. So I have a time, just like the time object, right? This is the first time object, 240. 2 o'clock at the end of a class. So I have a time, and so this array element is an object meaning that in the JSON. By the way, it's so easy to use JSON to represent objects so we can read, we can process, then the C++. C++, you must create a class. You must put constructor, a bunch of protected public. It's okay, but it slows down your development. Okay, so sometimes we like to use this kind of simple context for us to quickly nail down to the object. And then we can actually use this representation to do a lot of other things. Okay, so by the way, this is the object. An object has a multiple element. Again, they have a 2 element. The first element, first key value pair is time. And the second key value pair, the key is location. So the time, location, and again, separation is a comma. Okay, so when you read the JSON from this, from this curly bracket to this curly bracket, in between, you see there are 2 components, 2 key value pair. The first key value pair is the time. The second key value pair is the key is location. And now we're going to look into the location. Location itself is an object because the location itself, the location object, in our case, is GPS. And therefore, we have a location, we have a comma, and then inside here, I have latitude, longitude, and then I would like to put a label because I like to say, hey, not just about the GPS location, I want to see exactly what's the name I want to put it to represent that location. So in this case, by the way, sorry, the latitude, longitude, I kind of save time. I just put 1.0 and minus 1.0. It's a fake one, okay? You have to use Google Map to actually check exact value for the NCKU EE building, okay? Our current location. So neglect this value, but there is a one attribute is latitude is a floating point, and the second one is the longitude with a floating point. Remember, always separate with comma to separate multiple key value pair. I mean, if you forget about this, don't worry. When you write the program, you encounter error here and there, you will learn. Okay, you have to put that comma. If you don't put the comma, your program won't work. Okay, and then I kind of add a label. Okay, a label just helps me to easily represent, capture information. So the label is a string, and that is the location object. That is a time. So this represents the time, location as in the JSON format to capture the story. Okay, so just a one person, you can see that I can actually capture the GPS trace. Sorry, go back. This is the first timestamp. You see I have a second timestamp. The second element is from here to here. Okay, now you see that this is about 2:30. And forget about latitude, longitude. And the label is Changrong bus station. Okay, Changrong Road bus station. And then we look at the third one. The third timestamp is over here. You see that the format is the same, which is the time, location, latitude, longitude, and then NCKU hospital. And then the final one is this part. Is essentially saying that that's more in Pollock bus stop at in the afternoon, 3:15. Okay, so you can see that now I declare a new person called traceable person. And then what happened is that, okay, then I can include a traceable route about the GPS location and the time. So I can establish a footprint of a particular person object. And this information, I can actually get it out from the description, the natural language description above, and which helped me to capture the information that's matter to that person. Okay. Okay, any question about what I just talked about? You see, what I'm doing is just first step. I'll convert it from a natural language description to a JSON description about the object. Okay. No question? Okay, good. So I'm going to move on to the second step. The second step, before I go to the second step is once I create the object, I will start thinking about how the object are going to interact with each other, which is now we try to go into another step that's actually closer to solving the problem. But I want to pull back a little bit. I want to kind of look at the first step and try to convert the first step into the C++ code. Okay, I want to first tell you how to convert that to the C++ code, and then we're actually thinking about the rest. I think that order is good for you to learn the concept. Okay, so let's go back to here. So I hope you remember the element about the array we're dealing with. This is called traceable person. And I'm going to show you a piece of code, which I already showed you on Thursday. I want you to look at carefully. Look at the code compared to this description that I just put down here, JSON. I want to see what do you see is a problem or difference or inconsistency between this description and the code I'm going to show you. Oh, it's already here. So this is what we did last time. It's called traceable person. So you can see that I have a two extra attribute. Oh, by the way, just to let you know, you should know is I inherit from person. So traceable person is a person. Okay, this is the inheritance relationship. So I already have everything that you declare for person. But in addition, I introduced this two line. As I said, the first line is kind of trivial. Okay, I'm just adding an occupation. But the second line is more complicated because the second line I introduce another attribute called GPS trace. But this GPS trace is under another class called personal time GPS record. Okay, so essentially that array that we represent over here need to be represented in this particular class called personal time GPS record. So let's actually take a look what that is. Okay, so now we have a personal GPS record. Okay, I do have a inheritance called public core. So I'm not going to explain why I need to include that. That is for some reason I want to processing all the object in my system. So I declare something called core object. And don't worry about that right now. Right now, you just forget about anything that's behind that public core. Okay, but let's look at the personal time record. So the important thing is this line. The important thing is this line. This line is called time location traces. Okay, I want to make even more interesting changes. Let's try to get rid of this. Assuming I don't have the STD string identity. I just have an array of, actually it doesn't matter. I can keep it here. It won't hurt my presentation over here. So this is the line I have. It's called vector time location and traces. By the way, I should get rid of the and at this moment. I don't need to do that. Just make things less complicated. I don't want to confuse you at this moment about the difference between reference and the copy. Okay, so I'm going to do something looks like this. Okay, so let's focus on this line. I have to explain to you a little bit about C++ syntax. So what's the syntax of this one? Okay, I have to parse it a little bit. Let me first write down a traditional C representation about this. A traditional C representation will be looks like this. I will just say struct, time, location. By the way, in C, I don't sometimes even need to put struct, but right now I'm just using struct to kind of let you be familiar with the C syntax, some of the C syntax. And then I will say traces 2 million. Okay, so essentially, this line is similar to this line. This line is similar to this line. Essentially, you can look at this. This is basically, are you familiar with this syntax? Struct, time, location, traces, 2 million. I mean, this is like, you can say, you can replace the first two words, say integer traces. It's an array. So essentially, it's an array called traces. Each of the element in the array is a structure called time location. Okay, so these two, they're almost the same. But the difference, you see that I have to specify 2 million. But in vector, in C++, we made an important improvement such that you don't need to specify how many elements in a vector. You can just basically say, hey, it's a vector. That's it. So the syntax is a vector, and then with a smaller sign, greater than sign, and then in the middle is the class or struct or data type you want to represent. Okay, so we haven't talked about this concept, but whenever you see smaller than and greater than like this, that means this is a what we call template. So whenever in C++ you see this pair of this sign, that means it's a template. A template means that I have a template of something that you need to fill in some information, and then I will actually create a vector, which is exactly for that data type. We will talk about template in greater detail, but at this moment, I really just want you to know how to use it. But think about, you just follow this syntax, and essentially you're doing this. The only difference is that you don't need to specify the size of the array. Okay, the system will automatically figure out. So this is a great improvement because I don't know if you know. I mean, why 2 million? I mean, how many do we need? Maybe we need 3 million. Maybe we only need 3, which if the programmer need to figure out, then it's very likely it is either over allocate or it is actually causing a segmentation fault because it didn't allocate big enough. Okay, so this is just a representative array trace. Okay, any question? Syntactically? Okay, great. So in the future, you can actually try to use a vector yourself. This is the first, what we call the standard template library you learn, STL, from C++, called vector. This is probably the most commonly used standard template library, vector. You can use either vector or use a std colon vector. They're the same, okay? All right, so now we have to look at, okay, traces is an array of objects. Each of the objects is called time location. So we need to see what time location is. So let's now go deep into that. Okay, now we look at time location.h. So that's why in C++ program, sometimes you need to kind of travel through multiple files to actually go back all the way to the root about the information. So this information is called class time location. And let's take a look what it has. It has two things. It has a GPS DD, which is represent the GPS information. And then what's the JV time? Okay, that's naturally, right? So time location, I'm kind of finding a location with a time, which is exactly what we have here. So that's why when you have this representation, you can immediately one-to-one, you can actually combine, go back to a C++ design. I mean, in this case, you don't need to even define yourself. You can actually just reusing this time location.h. You use what we call personal time, the GPS record, as a container. Oh, by the way, I want to tell you what do I mean by container? I almost forgot. What do I mean by container relationship? Let me go back. So I want to tell you what's the inheritance. This is inheritance, right? Whenever you have a class, you have a column, and then with another class. This is a parent class or base class. This is a child class or derived class. This is inheritance. You know that, right? I hope. This one, let's go down here. This one over here is actually containment hierarchy. Why is containment? Means that this, when I define this class, I contain a vector of some other object. So essentially, the other object called time location, this particular class or this particular, the object creating from this class is being contained in another class. That's called containment. So I'm not inheriting whatever attribute from the time location, but the thing is the concept of the class or the object has been included in this class. This is called containment. So containment is just represent what attribute do I have. So usually for us to understand all the relationship among class, we have to follow both containment and inheritance hierarchy. The number one reason is that if I make a change to either the object that's being contained or the object being inherited, when you change it, you're going to change those objects either inherit from this class or they contain this class. So that's why in the object-oriented programming, we need two hierarchy. One is called containment hierarchy. One is we call inheritance hierarchy, such that you will have a bigger picture about what things you should or should not change, which other component will be affected. Okay, we'll have more detailed example about containment hierarchy later, but this is the first time I tell you the difference between inheritance hierarchy and containment hierarchy. Okay, let's go back to time location. I'm going to ask the most critical question. I hope you haven't fallen asleep. The most important question I want to ask you is this. So I said in the traceable person, I actually contain indirectly the GPS, the time location.h. And the time location.h contain GPS location and it contain the JV time. Okay, that's what happened. Okay, so now I want you to check. This class called GPS DD, I assume you know this class. And the information I'm actually providing down there, are they equivalent? Just look at the GPS information. Just look at this location information over here. This is the location information over here inside the JSON representation. And this is the GPS DD location. Maybe I will pull out the GPS.h. Okay, this is GPS.h. Are they equivalent? Are they the same? The up window and the lower window, are they the same? The answer is no. They're not the same. What's the difference? What's the difference between these two? The top one has how many attributes? 2. The top one has only 2 attributes. The GPS has 2 attributes, longitude and latitude. How about the bottom? I have a 3 attribute. I have 3 attributes, and the attribute is latitude, longitude, and then I have something called label. Okay, here is a challenge, and this challenge has been there all the time, and I want to tell you a tool to deal with this. So this is called, okay, I want to reuse a particular class. At this time, the class either is called time location.h or personal time GPS record.h. In either case, it has been defined. But the way they define, they're using the class GPSDD. They're not using the other class we're familiar with called label the GPS. Remember, we have 2 classes, the other class called label GPS. Let me pull it out, just remind you what we have been talking about. We have the other class called label.gps. And inside label.gps, label.gps, by the way, is inheriting from GPSDD. And inside there, they have one extra attribute called label. So it inherits latitude, longitude from GPSDD, but it adds another attribute called label, because that's label GPS. And when you look at the down here, you actually see that this is actually label GPS. This is label GPS exactly, right? Has 2 longitude, latitude, and then has extra. However, the class you want to use, which in this case is time location.h, is actually GPS. So we have this kind of 2 different representation, which they're almost the same, but they're mismatched by 1 attribute. So what should we do? I want you to think about, okay, how do we deal with this situation? I know this is hard question because you never thought about this. But let me tell you that I only have how many minutes? Oh, 2 minutes, great. I won't ask you, I will just directly say it. I have 2 ways to deal with it. Number 1 way is I just redesign. Okay, you have a time location.h. So I will create another class called time label location.h, right? I actually changed the time location.h, extended to be a time label GPS.h. And then instead of having this personal time GPS record.h, I actually say I create another class called personal time label GPS record.h. I can do that. If I do this, I actually be able to match exactly this format. But this is going to be very messy. I mean, we're talking about a small, less than 100 classes file. If you do this, if you do a 1 million, that within a few days of development, you're going to have 10 billion classes. Because every single little mismatch, you're going to introduce a new class. By the way, you're going to change the whole inheritance hierarchy, and then you're going to do very complicated things. And if I haven't told you, inheritance is the most difficult things to maintain, by the way, in object-oriented programming. So we should avoid using that. Okay, so if you want to create a new class, it's possible, but you have to do it with care. I want to tell you the other way to do it is called casting. It's called casting. So which means that I will be able to translate the class, which is a label GPS, I want to treat as a GPS.h. I want to treat label GPS as GPS.h. And then I'm going to store the whole information into the array. But when I really store in array, I actually insert label GPS as an information, but it has been treated like a GPS itself. Okay, this is called casting. Well, how do I extract the label information? The difference is the label information. What I need to do is I need to recast back. I want to cast back from GPS back to label GPS. And then I can treat that information. So starting from Thursday, the first thing I'm going to tell you is how do you do casting? Casting has two ways. Most people only know what we call upcasting, means that from a base, from a child, you cast yourself as a parent. For example, I'm a traceable person, I cast myself as a person. But on the other hand, in GPS, this is secret, you can actually cast down. I'm a person, I can cast myself as a traceable person. And this is so powerful, but it's a bit dangerous. But we can talk about that on Thursday. Okay, see you later. Bye.